All right, guys, welcome to Monday. It's good to see you guys on Friday. Hopefully, you enjoyed. Okay, let's see. We're gonna do 10.8 today. Friday we'll do a chapter review, and on Monday chapter test. So the chapter test is gonna be multiple choice. I got to make it. I haven't made it yet, so I can't use the one that I normally use, which is not multiple choice. But don't sweat. I will give you a chapter review like always that will match the chapter test. All right, here's your homework for tonight. Copy it down. I think almost all the people that did poorly on the quiz have already emailed me and asked for retakes. Good job for all those of you that did that. There's still one or two of you that seem to be quite satisfied with your F. That's not being a good, virtuous student. So send me an email. We can still make up that quiz. All right. Today we're going to do something that's very, 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 very messy. Graph paper is almost a must for this. It will certainly make your life easy. A lot of people do this with two different colored pencils or pens or something like that. Other people are just really careful in it's going to involve some shading, some light shading or some dark shading. And some people just make a god-awful mess when they do this. So for those of you that are really messy, we know who we're talking about. You got to be really careful with this. All right, so we're going to do two things today. I'll just say this: you guys already know all you need to know how to do this. I just got to give you one quick explanation because you've done this before. I told you things are going to get a little messy today, and they will. Yeah, that was pretty messy. Okay. So we're going to do something called system of linear equalities. Wait, we've done that before. No, we're doing systems of linear inequalities today. So I do want to remind you of what a system of linear equations looks like. Remember, system of linear equations or equalities. There were three techniques we used. We had the graphing technique. We graphed the two lines, find where they intersect. We had substitution, and we had elimination. Okay. Well, I just want to remind you of the graphing one. So when we did graphing, right, the one on the left there, we found where the two lines intersected. Today we're going to be doing a system of linear inequalities. So the one on the right isn't a system of linear equalities; it's just one inequality. So that's what we've been doing. We've been graphing, and remember, you get this region, right? So now what I need you to do is think about what would happen if we had two lines, right? Two inequalities. So, well, there would be first inequality. Well, there would be the second inequality. What would happen if we combine them together? Yes, just like that video, it's a doggone mess, okay? But here is the, the one thing that you need in order to do your homework. The solution to a system of linear equations are where the two lines intersect. The solution to where two linear inequalities, right, is not where they intersect, it's where the region intersects. So check it out. I got some shading that's blue. I got some shading that's yellow. The solution to this system of linear inequalities are where the two shadings come together. Notice that X that you get with the line will make four regions, top, bottom, left, right. Only one of those regions, in this case this one, is where the two shadings come together. Does that kind of make sense? Okay. Now just be careful. That's the Algebra 1 interpretation. When you get to Algebra 2 and pre-calculus, you get some other things that can happen. But this is good for right now. All right, so here's what we're going to be doing. We'll be graphing one linear inequality. We'll graph the second one, and where the two shaded regions come together, right, that will be the answer. All right, sometimes just doing one just makes a better explanation than talking about it. So we'll be solving linear inequalities by graphing, okay? If you need steps, here are the steps. You're going to graph the first inequality. You'll shade lightly. You're going to graph the second inequality. You're going to shade lightly. And where the two shadings come together, it will be one of those regions, top, bottom, left, or right. Where they come together will be the solution, okay? Now, like I said, some weird things can happen when you have parallel lines, when you have linear inequalities, but we're not going to see that, at least not this year. All right, so let me show you what it's going to look like. I'm going to give you two inequalities, and I will ask you to solve the system of linear inequalities. So step number one, we graph the first equation, or inequality. So let's see, the first inequality there, y is less than 2x minus 3. Luckily, it's already solved for y, so we just go right into the graphing part. So the y-intercept is negative 3. The slope is 2 over 1, so up 2 over 1, up 2 over 1. If we go in the opposite direction, down 2, left 1. Let's see, it's solid or dashed. It's dashed because it's less than, not less than or equal to. And then we pick a test point. Let's see, what does Mr. C always like to pick? I like to pick 0, 0. So I'm going to pick 0, 0 and see if it makes it true or false. 2 times 0 is 0. 0 less than negative 3, that's false. So look where 0, 0 is in relationship to that line. It's on the left side. So the left side is the false side. We shade the true side. Now, when you're doing this, if you have colored pencils, great. If not, just lightly shade it. Because remember, we're going to have another line here. Okay, so step number 2, we graph the second inequality. Y is greater than negative 2x plus 2. Hey, it's already solved for y, so we can immediately go to graph. So let's see, y-intercept of 2. The slope is negative 2 over 1, or down 2 over 1, down 2 over 1. If we go the opposite direction, then it would be up 2 over 1. This one's also dashed. Pick a test point for the blue. Let's see, test point for the blue. Yep, I can pick 0. This is where it gets messy. Pick the test point for the blue, 0, 0. Let's see if it makes it true or false. Negative 2 times 0, 0. 0 is not bigger than 2, so 0, 0 for the blue line. Remember, I'm doing blue line. 0, 0 makes it false, right? So I need to shade the true side, which would be on the other side of the blue line. So the right side of the blue. Oh, look at that mess right there. Okay? Can you see where the two shadings come together? Yeah, it would be this region right there. So now take your pencil and just, I mean, you don't spend 5 minutes making it really dark, but just make it darker so you can show that this is the shaded region. In the book, what do is they leave out, they only shade the common region, like they leave out the other shading, like the shading in red there and the shading in blue. But I think that's a pretty poor technique because it makes the blue side makes it true for one of the inequalities, the red makes it true for the other inequality. Okay. But yes, and I made it purple. The purple side, the purple region is what makes it true for both inequalities. Meaning any point in that purple region would make either one of the inequalities true. For instance, we can clearly see that, I don't know, 5, 0 is in that region right there. Well, 5 and 0 would make the top inequality true. It would make the bottom inequality true as well. Okay. Any other region might make one of them true, but not the second one. And then obviously negative 5, 0 would make neither of those two inequalities true because it would be in the region that has no shading whatsoever. Okay, but the answer is basically a graph and where the two shadings come together. Okay, if you check the back of the book, they will only show just the purple region where where the two regions come together. Okay, the second thing they can do is they can give you a point. Now, this is the same problem we just did, and they could give you a point and say, is that a solution? So let's see, let's find where 5, 1 is. 5, 1 is right there. Is it in the double shaded region? The answer is yes. Therefore, yes, it is a solution. That's how that kind of works there. Okay, makes sense? All right, let's just see one more. All right, so the top one's already solved for y, so we can immediately just graph. The y-intercept is 5. Oh, I'm already solving. I'm sorry, I'm solving the second one. You can do that at the start, or you can wait until you graph the first one. Either one is fine. All right, so back to graphing. Let's see. The top one, the y-intercept is 5. The slope is -1 over 1. Not -1 over -1, -1 over +1. So down 1, right 1, down 1, right 1. If you want to go in the other direction, so it would be 1 over -1, or a rise of 1, and then left 1. This time it's a solid line because it's greater than or equal to. Test point, obviously I'm going to pick 0, 0. Let's see if 0, 0 makes it true or false. We get 0 is greater than or equal to 5. That's false. Therefore, 0, 0 is in the false side. We need to shade the true side. Make sense? All right, let's make it messy. Second one, y is less than or equal to 3x minus 4. So a dot on the y-intercept of -4. The slope is 3 over 1, or +3 over +1. So up 3 over 1, up 3 over 1, up 3 over 1 if I continued. Or if we go in the other direction, it would be -3 over -1, or down 3, left 1. Okay? Once again, this one is a solid line. Notice we don't are really concerned where the two lines intersect. We're concerned where the regions intersect. All right, what's my test point? Yep, you guessed it. I'm going to pick 0, 0 again. So let's see, we pick 0, 0. So we get 0 less than or equal to -4. That's false. So what side are we going to shade on? Yep, the side that's not on 0. We're looking at the blue line now. The side that's not at 0, 0. So there's my shading. Where do the two hash marks come together, or the shading comes together? It comes together in that region. And I realize I just gave you 2 examples where it's that region there on the right, but it could be any one of those 4 regions. Okay, and then some weird things can happen when you have parallel lines as well too. Okay. So here's the answer we just got. Once again, they could ask you a question. Is 3, 1 a solution to the system? So where is 3, 1? Where is 3, 1? 3, 1 is right there. Is that in in the double shaded region? The answer is no, it's not. It's in the blue shaded region, but it's not in the blue red shaded region. So therefore 3, 1 is not a solution. Now you could substitute 3, 1 into each one of those inequalities. You'll find it makes it true for the bottom one, but it makes it false for the top one. Okay? And remember, for it to be a solution, it's got to work with both. All right, ready to do one? All right, grab your graph paper. You might have to hit the pause, because obviously I will talk fast through this. All right, let's go. All right, the first one, it's already solved for y, so we can go ahead and just graph this one. The y-intercept is -1. The slope is 2 over 1, so up 2 over 1, up 2 over 1. If we go in the opposite direction, it would be -2 over -1, or down 2, left 1. It's a solid line because it's greater than or equal to. Doesn't go through 0, 0, so I can pick a test point of 0, 0. I like 0, 0. And we get, hey, that's true. Okay, so 0 is bigger than or equal to -1. So if it's true, then my shaded region would be where 0, 0 lives. In other words, right there. Okay? All right, second equation, I got to solve for y first, so just subtract x from both sides, and we get that. See what I did? All right, let's graph. Y-intercept of +2, and the slope of -1 over +1, so down 1, right 1, down 1, right 1, or 1 over -1. In other words, up 1, left 1. That one's going to be a dashed line, and notice I can still pick 0, 0. Because blue doesn't go through 0, 0. So let's throw in a 0, 0, and 0 is, yes, smaller than 2. So where's the shaded region where 0, 0 lives? In other words, right there. Can you see where the double shaded region is? Yeah, now this one's on the, I don't know if you want to call that the left side. There you go. That is the region that makes it true. All right, so we just did three examples of solving a system of linear inequalities. All it does is combine knowledge that we've already done before. We make a big messy diagram. We find where the two shaded regions are, and that is the end. In other words, that's what you turn in, okay? If you check the back of the book, they're only going to show the purple region shaded. I think all their answers are in red, okay? So I have one problem for you guys to do. I want you to go ahead and pause the video. Go ahead and get to an answer here, and then I'll show you the answer, and then you'll answer, did your graph look like my graph? Okay, so go ahead and knock that one out. How'd you do? All right, so the first one, let's see, the y-intercept of -2, the slope of 3, so up 3 over 1. The second one, we solve for y. So we add x to both sides and divide everything by 2. So you would get, let's see, y is less than or equal to 1/2 x plus 3. Well, there are my two lines right there. Notice the second one had the y-intercept of 3 and a slope of up 1 over 2, and then the top one had a y-intercept of -2 and a slope of 3 over 1, so up 3 over 1. Both of those you can pick 0, 0 as your test point. So for the blue one, you plug in 0, 0, and it ends up being true. 0 is bigger than -2. And on the bottom one, you throw in 0, 0, and you do get, in fact, that 0 is smaller than or equal to 3. So you shade to the left of the red, you shade below the blue, where are the two regions that come together. Well, it doesn't look really purple, but you can see where the two regions come together. Make sense? Okay, so go ahead and answer the Google question number 2. Did yours look like mine? Basically, did your double shaded region match my double shaded region? Okay, so that was our first objective. Can you do this? The second objective, the examples I have, it has lots of colors in it. Okay, let's see. We got yellow, we got a darker green, and we got a lighter green. I'm going to call the, now remember I have problems with colors, so the very top region is not the double shaded region. The region on the left there is the double shaded region. Don't ask me why the book used those three colors. I would have chose better. Okay, so here's what you're going to do. I'm going to give you this picture. You're going to come up with the equations of the two lines. The equations of the two lines. It's not too bad. Okay, it's just double the work of what we had last night or over the weekend for homework or whatever it was. The last homework I gave you. I'm confused on the days here. Okay, so here's how it's done. Remember, as long as it's a non-vertical line, all equations are the form of y equals mx plus b. If it's a horizontal line, it's y equals k. If it's a vertical line, it's x equals k. Okay, so it doesn't matter which one you do first. I'll do the red line there first. So remember the steps are you pick 2 points. Hopefully one of them is your y-intercept. And you calculate the slope. So it looks like the slope is down 1 over 2 or -1 over 2. Does that make sense? And the y-intercept is 2, 3, 4, 5. And you plug those into your equation. So you get y is equal to -1/2 x plus 5. And then we pick a test point. So I'll look at the red line. Notice the red line is shaded underneath, not above, that's the blue, underneath. So let's see, 0, 0 is underneath that. So I need 0, 0 to be true because that's where it's shaded. So I need 0, 0 to make it true. So we do the math there. We get 0 equal to 5. Obviously, that's not true. So which one of the four symbols makes that true? Knowing that it's a dashed line, well, then it has to be a less than, right? So a less than is what, I'm not pointing to the right one here, but less than is what makes one of those four makes it true. So remember, it's less than, not less than or equal to, because it's a dashed line. Does everybody see that? So there is my first inequality. Y is less than -1/2 x plus 5. So all I got to do is the same process for my blue line. Okay, same process. It's not vertical, it's not horizontal. So I use y equals mx plus b. I pick 2 points, one of them being the y-intercept. So let's see, that's an easy one, up 1 over 1, so a slope of 1. The y-intercept is a -1, you see that? So therefore we get y is equal to x minus 1, or 1x minus 1 if you want to write the 1, okay? Let's see, can I use 0, 0? I certainly can. Is 0, 0 true or false? So it's harder to see, but notice where the shading is. It's to the left of that blue line or above the blue line. So 0, 0 needs to make it true. So I need to make that equation right there, 0 is equal to -1, true. So which inequality makes that one true? Obviously a greater than or a greater than or equal to. So which one is the blue line? The blue line is solid, so then it would be greater than or equal to. And there in the two yellow are my two answers. So those are the two lines. Does that make sense? Okay. Let's try one. Let's try one. We'll call it a day after this one. Let's do this one. Okay, so let's see. Where is the double shaded? Green is the double shaded region. So I'm not sure why they used yellow. Why didn't they use red? Okay, they have a red line. You think they'd use red shading. They got a blue line. They did use blue shading, and so the combination. Well, I guess red and blue would be purple, right? Is that how that works? All right, but anyway, the green is your double shaded region right there. Okay, so let's see. We'll do the red one first. So the y-intercept is a positive 1. There's a lattice point right there. So let's see. The slope will be down 1, so -1 over 2. So down 1 over 2, or -1/2. Okay? And the y-intercept is a positive 1. So we get y is equal to -1/2 x plus 1. Got it? If I'm talking too fast, rewind, pause here, one step at a time. Okay, so let's see, where's the shading on the blue line? The shading is underneath the blue line, so I need 0, 0 to be true. So I need that to be a true statement. So let's see, the only inequality that would make that one true for red, because it's dashed, would be less than. Okay, does that make sense? Okay, one more and we're done. All right, gotta do the blue line. Y-intercept is 1 again, and the lattice point, it doesn't matter which one you pick. I picked that one right there. So let's see, the slope for this one is up 1 over 2, so it's a positive half, right? So positive a half. The y-intercept is a 1. So we write the equation, y is equal to 1/2 x plus 1. Can we use 0, 0? We can, and the shading for the blue is below it, so we also need it to be true. It won't always be true, but for this particular one, we need it to be true. So I need that equation right there, 0 equals 1 to be true. We know it's a solid line, so it's either less than or equal to or greater than or equal to, and the only thing that makes 0 equal to 1 to being true would be less than or equal to. So there is your second equation. Okay? Makes sense? Hopefully so. If not, send me an email. I'd love to help you if you need assistance. Okay. One quick note for homework, the book only shades the shared quadrant. So, the one of the 4 quadrants that's true. Okay? So look at the shaded region and you can figure out which way the shading goes for each one of the lines. Okay, hopefully that makes sense. If not, like I said, just shoot me a quick email and I'll help you out. All right, so that does it for today. Here's your homework. And let's see, this is Wednesday's class, so I will see you on Friday.